Now we are going to talk about gases. If you remember back to physical science, they talked about phase changes, kinetic molecular theory, kinetic meaning motion, molecular, think molecules. We talked about this a little bit also when we studied specific heat, the Q equals MCAT equation. And we talked about how if you increase temperature, you speed up the molecules. To change pressure in a gas, you can do one of three major things. You can change temperature, you can change the volume of the container, or you can change the amount. And when we say the amount, we mean the number of moles and number of molecules, which we describe using our friend the mole. Now keep in mind, when we change these, if we increase pressure, we're looking at what does that do to the motion of the molecules. Pressure in a container is related to the intensity and the frequency of collisions with the gas molecules and the side of the container. When we say intensity, we mean how hard are the molecules colliding with the other molecules as well as the size of the container. And when we say frequency, we mean how often are the collisions with the molecules and the size of the container occurring. The gas laws we'll be studying will focus on these relationships. When speaking about molecular motion, address these three components and you will have covered what you need to in a short essay or in order to understand the scenario to answer a multiple choice question correctly. Address the speed. Is what's happening to the gas increasing or decreasing the speed of the molecules? Or perhaps there is no change in the speed. Usually if there is a change in speed, for example, if the speed is increased, the intensity of the collisions will increase. If the speed decreases, the intensity will decrease. If the speed increases, collisions will be happening more often. And if the speed is less, they will be decreasing. A few notes before we begin. Every time temperature is used in a gas law equation, you must state it in Kelvin. This is the scale utilizing absolute zero, which is the point at which all molecules and their molecular motion stop, meaning the molecules will not even vibrate. The conversion in order to do this is take your degrees of Celsius, add 273, and you will have the temperature value you need in Kelvin. You need to know that pressure has many different units. Torr, millimeters of mercury, atmospheres, pascals, kilopascals, and pounds per square inch. 760 torr is equal to 760 millimeters of mercury, which is all equal to 1 atmosphere, equal to 101,325, or 101,325 pascals, which is 101.325 kilopascals. And this is all equal to 14.7 psi. Now, what does this mean? This means we can make some conversions in case we need a different unit. Now you'll notice I'm drawing the infinity symbols because for our purposes you will not need to worry about sig figs for torr, millimeters of mercury, or atmospheres. Those are considered exact numbers. However, here in our pascals, this is a rounded number of 5. Our kilopascals, rounded number of 5. And 14.7 is 3 unless we add a 0, in which case 4 sig figs. Now remember, all these expressions allow us to convert. So let's practice converting. Before we convert, I want you to keep in mind that what we are dealing with right now is standard temperature and pressure, what we call STP. We've seen this before, and when we've done this before, you've used 1 mole of gas at STP is 22.4 liters. And that's wonderful. But what you need to realize is as we change these conditions with the gases, they will not always be at STP. So you will need to ask yourself, do I have standard temperature pressure, in other words STP, or not? If you do, you will be able to use 1 mole equals 22.4. If you do not, you will have to use a different law, and we will get to that later. STP is defined as 0 degrees Celsius, which is 273 Kelvin, 1 atmosphere, and the volume of 1 mole of gas at STP is 22.4 liters. Keep in mind 3 sig figs here. Now, let's work on some conversions. For example, if I have 1,934 millimeters of mercury, I'm going to start my problem with 1,934 millimeters of mercury. And we're going to draw our line because we know when we convert, we put the unit we want to cancel on the bottom and the unit we're going to on top. If you go back to our equal expressions and you look at your notes, you'll see that 716 millimeters of mercury is equal to 1 atmosphere. And if we plug this into our calculator, keeping in mind that these two numbers are infinite and we're not worried about sig figs for those, and our starting number is 4 sig figs, you will get a calculated answer of 2.545 atmospheres. Now, if we wanted to solve the next conversion, again, the same process that we've been doing all year. 43.5 kilopascals. Kilopascals on the bottom because we want that to cancel. The unit that we're going to on top because that's what we need. When we look back at our equal expression, we will see that there is 101.325 kilopascals equal to 760 torr. And when we plug that into our calculator, we will round 3 sig figs here because that's less than the 5 here. And we will get 326 torr. Now I'd like you to practice the next two on your own, again using the equal expression that you were given prior in your notes to create your fractions in order to cancel your units utilizing unit analysis or dimensional analysis to get to the unit that you're going to. If you've done that, you may want to check your answers now. If you're still working, please pause the video. Now, if you've unpaused the video and you're checking your answer with me, you should have come up with 237,000 pascals. I apologize, this should be pascals. Atmospheres to pascals. And this one should be 573 millimeters of mercury. Here are some standards and conversions that you may need to use. Here's your Kelvin temperature conversion, just to remind you again. Here are your pressure units that you may come across. Your gas conversions that we just practiced with, and the reminder about standard temperature and pressure conditions. All of this background information will help you with mathematical calculations that we will be doing involving gas.